In this video, we will continue with revision exercise 6, differentiation. You will find this on page 307 in the Namibian AS-Level Mathematics textbook, Y equals mx+c to success. I want you to stop the video and I want you to do number 4 as well as number 5. Again, you can continue the video as soon as you are finished. Okay. Let's start with number 4. The diagram shows the curve with equation. The minimum point on the curve have coordinates a0 and the x-coordinate of the maximum point is b, where a and b are constants. State the value of a. Okay, it's a curve, stationary points, I differentiate, I put the stationary points equal to 0. So let's start. Let's first write down the curve. So this is going to be x, and this is going to be x minus 2 squared. Now, I'm not going to work with it like that. So I'm first going to multiply out this. This is x squared. If I'm doing this short, multiply with each other, multiply 2. So negative 4x plus 4. Sometimes that I keep on wanting to write there negative. Okay, but it's positive always. So it's x to the power 3 minus 4x squared plus 4x. Okay, now I can go and differentiate. So if I differentiate, I'm getting 3x squared minus 8x plus 4. Okay, now at the stationary points, points dy over dx is equal to 0. Meaning that I'm going to put a 0 there, and then I'm going to factorize. Now let's see 2 and 2 and 3 and 1, because it's in group A, so it's going to be 6 plus 2, and that's 8. The signs are the same, negative, negative, x, x. So it's going to be 3x minus 2 and x minus 2. So therefore, x is equal to 2 over 3, or x is equal to 2. Now, just from the graph, you can already see that this is going to be 2 over 3, and this is going to be 2. But let's ask, they say state the value of a. Now, you could have actually see it from the graph also there. It was not necessary to do that, because actually you can see that that is double and that will be 2. So that's why they just say state. So you could have actually already see that a was 2. Okay, but you can also see it out of that. Now, unfortunately, I already did that, but it doesn't matter. They will always look up. So calculate the value of b. So I can actually say that, let's just take another color. I could have see that that was 2, and I could have made that my b part. And it's right. In the exams, you can do it like that. Just write it like that. And then just go and then just say, okay, this is now my b. So therefore, what is the question? Calculate the value of b. So I'm just going to say b is equal to 2 over 3. And that is going to be my answer. Okay. Now I go on. The gradient, okay, and now this is almost, I want to say almost like a catch out, because it's like a bit confusing in the beginning. They say the gradient, that means that equation. They refer to this equation. Okay, let's rather take another color. What will we take? Green. They refer to this gradient formula. Okay, so they say of the curve has a minimum value. So it's almost like they want, it's another graph. They're not referring to that one anymore. They talk about this one and they say this curve, this green one, has a minimum value of m. Calculate the value of m. So it's actually like I'm going to take this formula now, dy, it's still dy over dx, but I'm going to differentiate it again. It's now, as I said, my new curve. So if I differentiate it again, then I'm going to write it as d squared y over dx squared. And if I differentiate, again, I get 6x minus 8. And again, the stationary point, so stationary point when d squared y over dx squared equals 0. So when this is 0, okay. So I'm going to now just quickly, I'll just substitute. So I get 6x is 8. So if I divide 6, I get that the value of x is going to be 4 over 3. But that's just the x. They want the minimum. So they actually want the y value. Now, how do I get the y value? So at x equals 4 over 3, and that is the y value I'm talking about. Dy over dx, and now you just go with 3, 4 over 3 squared minus 8, 4 over 3 plus 4. Okay, and if I simplify this now, I'm just going to get 16 over 9 minus 32 over 3 plus 4. And if I simplify that, I'm going to, and this is actually interesting, negative 4 over 3. So I can answer the question, okay, by saying, therefore, I want to just let you read the question again. Calculate the value of n. Give us a minimum value of n. Therefore, minimum value n equals negative 4 over 3, or negative 1 1/3. Doesn't matter. Okay. So it's a bit challenging just because they actually take it almost as a new equation and they want you to do exactly the same, finding the stationary points. Okay, and then we are at the final one, and that is number 5. Okay, I just want to make sure I have enough space. Sorry. Come on. Okay, there it is. And let me just go. And I just want to break this also. And then I can move it a little bit up. Okay. Let's start with the last one, number 5. The diagram shows a metal plate consisting of a rectangle, you can see that, with sides x and y, and a quarter circle, you can also see that, of radius x. Okay, this is very important, that this is also the radius, and that is x. Okay, the perimeter of the plate, so the distance around, is 60 centimeters. Express y in terms of x. Now, if you're going to start with that one, you're first going to start with the formula for the perimeter. Now, the formula for the perimeter, and let's just check it the way around. Okay, so if this is y, I'm just going to go the other. Let's rather start this way. I'm going to take a quarter circle. Then that is only that part. Then I'm going to take the x. Then I'm going to take the y, going the distance around. And then I'm going to take another x. And then I'm going to take another y. Okay, so basically, and I have this. But let me just, that was basically the distance around. I just didn't want to scratch so much. It's 60. So let's just go and say 60. That's a quarter. Now, what's the perimeter of a circle? 2 pi, but you have r. Remember that I said this is r, but it's actually x. So, x plus that 2x. Is there, let's just see. Yes, because that's x and x. That's why it's 2x. Plus 2y. Okay, let's just simplify it further. Okay, so basically, let's just multiply, let's just get rid of, no, I'm not going to first do that. Let's keep it like this. Let's make it a half pi x, okay, plus 2x plus 2y. Okay, now I'm just going to basically take this over. Okay, let's just see, this was a quarter. They want, let's just look what they want. Express y in terms of x. Okay, let's just get rid of the half. So if I get rid of the half, I multiply with 2 over 1, 2 over 1, 2 over 1, 2 over 1. So I'm basically, let's just go to green again. I'm going to get 120. This is going to be pi x because the 2. This is 2, so it's going to be 4x. This is going to be 4y. Okay. Now I want y. So make the 120, subtract the pi x, subtract the 4x, and that's going to be 4y. Okay. And now I divide 4, I divide 4, I divide 4, I divide 4. So I'm getting, so 120 divided 4 is 30. And that's a quarter pi x, and that's just x, and that's y. So therefore, I'm going to make it red, that it stands out a little bit. Y is equal to 30 minus x minus a quarter pi x. Okay, that's what they want. Express y in terms of x. We go on. Show that the area of the plate is given by that. Okay. Now first, you're going to start by first say, how do I find the area of that plate? So area, plate, is the area of the rectangle plus the area of the quarter circle. Okay. Now, what is the area of the rectangle? Length times breadth. What is the area? It's a quarter pi r square. Okay. So, if I'm going to look at this one, I'm going to say, okay, y plus a, multiply x, plus, okay, just remember the radius is x. Can you remember? The radius is x. So, a quarter pi x square. Okay. Now, if I'm going to, and I'm going to show you now, okay, let's just get this quickly. Okay, this is not looking nice. Okay. If I'm going to take now this, do you see the y, and I substitute it in there. Okay. So let's do that. I want to keep to yellow. So in the place of y, I'm going to substitute now 30 because I want it just in terms of one unknown. 30 minus x minus a quarter pi x, okay, plus a quarter pi x square. Okay, and that's going to be 30x minus x squared. Now, can you see? Minus a quarter pi x squared plus a quarter pi. Oh, that is nice. I always like it if things cancel out. Okay. And that is just going to give me that 30x minus x squared. Exactly as they gave me there. And I always say it in this question. Say, for example, you were not able to do A and B, then at least try to go on with this answer and see if you can do C and D. Okay, so don't just say, oh, I cannot do it and just leave the whole question out. Okay, but now, find the value of x at which A is a stationary. So now differentiation. Stationary points is always differentiation. So now I will go and say, let's just see. So dA over dx, and that's going to be 30 minus 2x. Okay, So at stationary point, dA over dx is equal to 0. So basically, 30 minus 2x is equal to 0. So 30 is equal to 2x. So therefore, x must be equal to 15. Okay, let's just see what the question is. The question was saying, find the value of x at which AS is that is 15. That's going to be your answer. And then I go for the finals. And I think I'm going to do the D here. Okay, just that I see a little bit better. So let's just do D there. Find the stationary value of A and determine whether it's a maximum or a minimum value. Find the stationary value of A. That means I'm just going to take my formula of A. Can you still remember? 30x minus x squared. And that 15, I'm just basically going to substitute. So it's 15 minus 15 squared. And if I press that on the calculator, I'm going to get 450 minus 225. And that is going to give me 225. Okay, say if this was in centimeter, then it will be centimeter squared. But now, okay, so they asked me the area, and then they asked me the nature of the point. So I'm going to double differentiate. I'm going to take this differentiated formula, and I'm going to differentiate it again. So I'm going to say d a squared over d x squared. Okay, sorry, I was writing it incorrect here. Let's just rewrite it correctly. So it's d square a over d. It's almost like the squares is opposite. So that's why I realized I was making a mistake. If you then it's going to be negative 2. And you can see it's smaller than 0 or it's a negative value. So you can end up by saying, therefore, a maximum value of A. And that's how you do it. Not so difficult.